Right, so let us look at electric current. Now, before we start electric current, we do need to understand what is a charge. Now, charge is a fundamental property of matter. Electrical devices work when an electrical current passes through them. And we know that different particles have different masses, which are all affected by gravitational force. Now, in a similar way, particles can carry different amounts of electric charge, and they are also affected by electrical force. But there is an important difference. Unlike mass, charge can be positive or negative. Now, two particles that carry the same sign of charge will repel each other, and two particles with opposite charges will attract each other. Now, these electric forces between charges, they keep atoms stable and hold the atoms together as molecules. Now, atoms do have negatively charged electrons, which are attracted to the positively charged nucleus of the atom. So atoms as a whole are electrically neutral, but they can become ionized. Now, if an electron is added to an atom, a negative ion is formed. And similarly, a positive ion is created by taking an electron away from the neutral atom. And the size of the force between the charged particles, such as these ions, it depends on the magnitude of charges, which kind of brings us to how the charge is represented. So charge is represented with the symbol capital Q. And the measure of charge is in coulombs. And we define 1 coulomb as the charge of a single electron, which is 1.6 minus 1.6 into 10 to the power 19 coulombs. So that's it. That's the charge. That's quickly about the charge. So having learned about charge, now let us look into conductors and insulators, that is the properties of materials to allow the charge to pass through them. Now, when we talk about this conductors and insulators, one important concept is the concept of conduction. So a material, basically conduction is just an idea which shows the flow of electric charges through a material. That's what the idea is. Now, an insulator is a material that does not readily conduct electricity. Examples include glass, plastic, and air. Now, importantly, an insulator has no charges that are free to move through it. So the electrons in its atoms are very tightly bound, which means that a relatively large amount of energy on an atomic scale is needed to free one electron from the atom in an insulator so that it becomes mobile and it can take part in conduction. Now, for example, in glass, this force would be around 3 electron volts of energy for each electron. So this is a pretty large number for the atomic scale. Now remember that it is possible to add extra electrons or remove them from an insulator to leave it with a net charge. Now this can be easily done by rubbing two insulators together. So when you brush your hair or rub a balloon on your jumper or even stroke your cat, you will remove electrons from one surface, leaving that surface positively charged, and add them to the another, making it negatively charged. Now, these charges will remain on the surface, and the two surfaces will then attract each other. So objects that carry similar surface charges, either both positive or both negative, will repel each other. So having looked at insulator, let's understand what a conductor is. Now, an electrical conductor simply allows charges to pass through it relatively easily. So metals are good conductors principally because some of their atoms are free to move around between, some of their electrons are free to move around between the atoms. And it is possible to add charge to a conductor, such as the metal dome on a Van de Graaff generator, and the charges will move and distribute it themselves over the surface. So if there is a conducting path to the earth available from the surface, the charge will leak away. So that is it about a conductor. Now let us look at current. Now, you may be aware of the effects with balloons, hairbrushes, lightning, and something like a Van de Graaff generator. These are all due to objects gaining a net charge. And these are referred to as electrostatic phenomena. So static means not moving. And what this means is that there is no continuous flow of charge. When charges do flow continuously, for example, electrons around a closed loop of a conducting wire, it is referred to as an electric current. So the main idea is that there is an involvement of a continuous flow. Now, this flow could be the flow of electrons in a metal wire, or it may also be positive and negative ions moving through a battery, or it could be a beam of protons in an accelerator. The basic idea is whenever there is a flow of charge, we define it as current. Now, the size of the current, I, is given by the amount of charge passing a point in a given time, or in other words, current is simply as the rate of flow of charge. And it can be given by this equation, I equals delta capital Q divided by delta T. So in words, it is simply the rate of flow of charge per unit time. So the way we measure current is called ampere. And in a circuit in which you have a current of 1 ampere, it means a charge of 1 coulomb is passing a given point every second. That is how we define 1 ampere as. Now, it's important to understand a couple of notions about how we measure the direction of the current. Now, conventionally, the current is assumed to be that of a positive charge. That's just a convention. That's how it was thought earlier. So, from a conventional perspective, we assume that current is flowing from a positive terminal to a negative terminal. However, we know that current is the flow of electrons in most of the cases in conductors, for example, an electron goes in the conducting circuit in the opposite direction. So that is it. That was a very quick introduction to the electric current.